So this is our third module, statistical inference. So let me define few definition. Okay, so in statistical inference, a population in statistical language is a collection of individuals or attributes. So first of all, note that what is a population. Population means uh, it's a collection of individuals or attributes. Okay, and this population may be finite or infinite depending upon the number of elements is finite or infinite. So there may be population may be finite or infinite. Now what we will define is sample. Okay, sample. So a finite subset of a population. A finite subset of a population is called a sample. If there are infinite number of elements in the population, if we take a finite number of elements depending upon some criteria or condition, then that finite subset is called a sample, and the process of selection of such samples is called a sampling, and the process of collection of such samples is called a sampling. And sampling is very important topic because we make data analysis by using samples, not whole population, but we will take some samples and we will analyze and we will make inference about the population by using this sample. So the sampling means the process of selection of such samples. Okay. Okay, so the basic objective of theory of sampling is to draw inference about the population. So that means we have to draw the inference about the population by using some few samples. Okay. If xi be the value of x for ith member of the sample, then x1, x2, etc. xn are referred to as a sample observations. Now we define what is parameter and statistics. So parameter means statistical measures such as mean and variance calculated on the basis of population values are called parameters. Okay. So the mean and variance statistical such measures are called parameters, and the observations are called statistics. Okay. So the probability distribution of static may be that would be obtained if number of samples each of same size were infinitely large is called a sampling distribution of statistics. If number of samples size is large, then we can find the probability distribution, and that distribution is called the sampling distribution. And the standard deviation of the sampling distribution is called the standard error of the statistics. So we have to note these definitions. What is parameter? Parameter. Parameter means mean and variance of the sample distribution, and static, the observation, and what is standard error is the standard deviation of sampling. So now we will define what is confidence interval. So this is very important topic. So the thing is the actual sample observation x1, x2, etc. xn are assumed to be the result of random samples x1, x2, etc. xn from a normal distribution with the mean mu and standard deviation sigma. And we know that if we are taking random variables with the same mean and variance, If the number of samples are very large, that follows some follows normal distribution. Okay, by central limit theorem. Okay. Now the sample mean x bar is normally distributed, that we already studied in from central limit theorem. Mu and standard deviation sigma by root n. And last class we discussed x bar follows normal mu by sigma by root n. Mu sigma by root n. So now, now we will define what is confidence interval. The standardization. Okay. The standardization x bar by subtracting its expected value and then divided by standard deviation in get normal distribution. So we know that x bar follows normal mu sigma by root n. Then we know that z equal to x bar minus mu by sigma by root n follows normal 0 1, that is standard normal. Now look at this, the area under the standard normal curve from minus 1.96 to 1.96 is 95%. So if we take the normal table, so look at here, up to here, to here 0 point, total area is 0 point, sorry 1, total area of this portion is 1, right? So up to 0 to here 0 0.5, right, 0.5. So if I take 1.96 minus 1.96 minus 1.96, so if here it is minus 1.96, so I will draw here. So this normal distribution, if here it is minus 1.96 and here it is 1.96, so this area, so this probability, this is 0.95 total. Okay, because we know that up to here the value is 0.0250, right? 0.0250. So this area is 0.0250, and also now we have to calculate that nine point, okay, and remaining area, that means this area is also 0.025. So this total area is 0.95. So probability of, so from the normal table we have probability of minus 1.96 less than or equal to x bar minus mu by sigma by root n less than or equal to 1.96 is 0.95. So this is the probability. That means, which implies from here we can take minus 9.6 into sigma by root n. I am multiplying both sides. x bar minus mu uh, less than 1.96 sigma by root n. So we don't know population mean. We will assume population mean will be in the interval. Okay. So this is minus x bar. If I subtract x bar minus x bar from here, so you will get so therefore you can write x bar plus 1.96 sigma by root 10 less greater than mu. I'm multiplying with minus 1 x bar minus 1.96 sigma by root 10. So which implies x bar minus 1.96 sigma by root 10 less than mu less than x bar plus 1.96 sigma by root 10. Therefore, and this probability of mu in between these values is 0.95. So the probability of x bar minus 1.96 sigma by root 10 less than mu less than x bar plus 1.96 sigma by root 10 is 0.95. So this implies that the population mean, unknown population mean mu, has a 95% confidence interval x bar minus 1.96 sigma by root 10 x bar plus 1.96 sigma by root 10. അതായത് നമ്മുടെ mean, unknown mean of the population. We don't know what is the population mean and we only know the sample mean. And we can have a 95% confidence that the mean population mean will be in this interval. So that is the 95% confidence. Okay. So now what will be 99% confidence interval? So here 95, I want 99%. So that means if this is the normal table, I want this value. Means in this area is 0.99. I want this value. So here 95 confidence interval, the value is minus 1.96 and 1.96. That is Z alpha by 2. Okay, now okay, now we will, from the normal table we will find the value is 99 confidence interval. The value is minus 2.58 to 2.58. You can check from the table. Minus 2.58 or 2.58, right? Minus 2.58, 2.58. minus 2.58. This is 0.049. Okay, so up to this, so this area is 2.58 minus this is 0.49, 5, and also 2 minus. Okay. So this interval is 99, 0.99. So the confidence interval of 99% confidence interval is we will get x bar minus 2.58 sigma by root n and x bar plus 2.58 sigma by root n. So similarly, we can find 90% confidence interval. 90% confidence interval, we will get this x bar minus 1.45 sigma by root n x bar plus 1.645 sigma by root n. So similarly, you can find any percentage, 80% confidence interval, 96% confidence interval. Similarly, you can find this value and you can make an interval. So if most of the case they will know if ഏത് കോൺഫിഡൻസ് ഇൻ്റർവെല്ലാണ് തന്നില്ലെങ്കിൽ നമ്മൾ 95% കോൺഫിഡൻസ് ഇൻ്റർവെല്ലാണ് ചൂസ് ചെയ്യുക. ഓക്കെ, ആസ് otherwise in the question itself they will give 90% or 95%. Now okay, there is so in general for mean mu and sigma is known. So in order to make a confidence interval, you have to know what is population standard deviation. If we know population standard deviation and sample mean, we can find an interval where it has 95% or alpha by 2% confidence that mu will be in that interval. So there is one more thing. The sample size necessary for the confidence interval to have width W is equal to, there may be a question, width W is equal to, we need a sample size n equal to 2 into Z alpha by 2 sigma by W whole square. Okay. So this is the sample size we need with the width W. Okay. Width W, we need a sample size. So if here one thing, let us do once more. If sigma is known and mu is unknown, then we can find the confidence interval 95%, 99%, etc. Because here all sigma is known, that is population standard deviation. We don't know what is mean. Now if n is sufficiently large, even if we don't know population standard deviation, still we can use sample standard deviation. If a number of samples is very large, then the interval is, you can use sample standard deviation. So the confidence interval with Z alpha by 2 or Z 0.955 by 2 is equal to x bar minus Z alpha by 2 s by root n x bar plus sigma z alpha by 2 s by root n. So if sample size is very large and mu is unknown, and even if population standard deviation is unknown, we can use. So I will do a problem. Okay, so we can do a problem. So problems are very easy. Okay, so consider a study. Consider a study of preferred height of an experiential keyboard with a large forearm wrist support. A sample of 31 trained typists. So sample size is 31, n is 31, was selected, and the preferred keyboard height was determined for each typist. So we want to find the preferred keyboard height. Assuming that preferred keyboard height is normally distributed with a sigma 2 centimeters. So population standard deviation sigma is given, and the sample average preferred height was 80. X bar is 80. So sample average is also given. X bar is equal to 80. Obtain a confidence interval to the average preferred height for the population mean. So here there is ഏത് percentage confidence interval ആണെന്ന് പറഞ്ഞിട്ടില്ല. അപ്പം if it is not given, we will take 95%. Okay. So solution, n we have given, sigma given, uh, x bar is given. For 95% confidence interval, we have for mu, we want the average value mu, population mu is, we know that it is x bar. This interval you have to study, x bar minus 1.96 root sigma by root n, and x bar plus 1.96 sigma by root n. So this is the interval. Now that interval here is given. So x bar is 80. 80 minus 1.96, sigma is 2 divided by root 31. 80 plus 1.96 into 2 by root 10, root 31. So the confidence interval is 79.3, 80.7. So mu will be in this interval with a percentage of 95% of chance you have mu in this interval. So that is the confidence. Now I will do one more problem. Next is also very easy. Problems are very easy. The production process for engine control housing units of a particular type has been modified. The distribution of all diameter for bushings on the housings was normal with a standard deviation. The standard deviation is given, population standard deviation 0.1. A sample of 40 housing units is selected. So sample size is 40. And hole diameter for each, resulting in a sample mean. Sample mean is given 5 point, x bar is given 5.426. Calculate the confidence interval for true value of hole diameter with a confidence interval of 90%. So here confidence level is given 90%. So we have to do that. If it is not given, then we will do 95%. So here it's given x bar n, sigma is equal to 0.9, 0.1. 90% confidence interval is x bar minus 1.46 sigma by root n, x bar plus 1.645 sigma by root n, then 5.426 minus 1.4645 sigma 0.1 root 40 is 5.426 plus 1.645 0.1 by root 40. So the interval is 5.4, 5.452. So there is a 90% of chance that mu lies in the interval, that is population value, population mean lies in this. So next problem is I will give next problem is a different type of problem. So just last problem. So here we have to find out the sample size. Existence monitoring computer time sharing system has suggested that response to a particular editing command is normally distributed with a standard deviation. Sigma is given 25. A new operating system has been established and estimate the true average response mu for the environment. Okay. Assuming that response times are still normally distributed with sigma 25, what is the sample size necessary to ensure 95% of confidence interval with a width at most 10? So we want width at most 10. So there is a 95% confidence interval means z alpha by 2 is 95 by 1.96. Okay, so we know that the size of width and sample size, that is n equal to 2 z alpha by 2 sigma by w whole square, and we know that 2 into z alpha by 2 is 1.96 and sigma is 25 by 10 whole square. So we will get 96.04. So n is an integer, therefore we will take 97. So there required 97 samples to get that confidence interval with width 10. So these are the problems. So I will share notes to you, and more problems. I will share more problems. Okay. So anybody have any doubt?